Audio Jungle. Audio Jungle.
Here in this session we are going to discuss about classification of source elements. Classification of source element means we are categorized into dependent. Again, under that we even made into voltage, current, like ideal, practical, what kind of dependent sources. That is the main objective in this session. Okay, so again we are even defining that different sources and drawing the characteristics. All these are present in sequence here. Now first, if you look at that, sources are categorized into independent, dependent sources. Observe here, independent sources again we categorize into voltage as well as what, current. But again we even classify them into ideal voltage source as well as practical voltage source. Next one, ideal current source and practical current source. These are all what independent source elements. Next classification is what, dependent source. Even we call them as what, controlled sources. You can call it as a dependent source or controlled source. What kind of sources present? Definitely a source means it must be either voltage or current source only. But how that particular source is depending on another variable, based on that we categorize them into 4 dependent sources. That is, you can name voltage controlled voltage source or voltage dependent voltage source. You can use the term dependent or controlled, there won't be any change. Next one is what, voltage controlled current source, current controlled voltage source, current controlled current source. This is just a classification here. Okay, so sources how we categorized, right? We observed here. Next we'll see in the sequence one by one how we are going to write expressions for ideal, practical, voltage, current source. We will see. First we will see voltage sources part, means independent voltage sources. Again in that we categorize them into ideal and practical, right? Independent means absolutely there won't be any dependence on other variable in the circuit, just represented with some potential difference. Okay, that is the value of that particular voltage source. Okay, and again how we differentiate the word ideal and practical, we will see here. First, ideal, if you see how to define that, when it comes to the definition part, ideal voltage source means generally a source means we are connecting it to the circuit, or connection means definitely happening to only 2 terminals. When you connect it to that particular terminals, okay, so terminals means again it can take the word voltage or current. So how to give the word definition in terms of the terminal voltage, current and this particular voltage value. Okay, suppose if I am considering voltage source means, as we mentioned here, we are indicating with some potential difference. Suppose if I am following with this polarity, okay, so I am indicating even that source. So it is a kind of source I am indicating with the notation like V suffix S, Vs, and these are the what, 2 terminals, right? Here only you can connect element here or the circuit, whatever it is, 2 terminals as I mentioned. I am assuming some terminal voltage. For example, if you add any element here, some terminal voltage I am representing, that is with what, Vt, terminal voltage, load voltage, terminal voltage, whatever the notation you can take, but I am just following with the terminals point of view, Vt, and some current will be flowing through it. Okay, this is what, some current is flowing. If you connect it to that element, some current definitely flows here. Now how to give the statement for this independent ideal voltage source? Here terminal voltage is independent of current flowing through it. Current, this is the current only flowing from source to that particular element or terminals. If the terminal voltage is independent of this current, then it is what? Ideal voltage source. Anyway, it is independent only because there won't be any dependency on the what variable in that particular circuit, so it is independent only. But especially if this terminal voltage is independent of this current, whatever the value of current flowing, always this voltage is equal to this particular source voltage or applied voltage, then it is what? Ideal voltage source. Otherwise, simple, if you imagine that it is a what? A closed path, because I am assuming some terminal or some element is connected and it is associated with this voltage Vt. Anyway, up to now we didn't focus on much on that KCL KVL, but still we have to use them to write the what expression here. I'm just following with KVL here, Kirchhoff voltage law. What is that statement for that? In a closed path, means you can apply the KVL for any closed path or loop. Okay, but here loop we are not indicating, but I am assuming that if a particular element is connected, then automatically closed path will come, and I am assuming some voltage across that element, that is what? Vt. So terminal voltage I am considering. Now, what is the statement? The algebraic sum of voltages in a closed path is 0. Suppose if I am following with this direction, okay, if I am following with this current direction, so how to indicate that even polarity for that particular voltage? If I am following with this current direction, current entering into this negative terminal, I am imagining with what? Negative sign, and current entering into positive sign, I am assuming with what? Positive sign, because I am writing algebraic sum of voltages in the closed path is 0. Only these are the voltages available here. So plus Vt is equal to 0, right? If I am following with this closed path, current entering into negative terminal, I am considering with what? Negative sign. Entering into positive sign, I am considering with what? Positive sign. So algebraic sum of voltages in a closed path is 0. With this expression, what you can relate? Okay, Vt is equal to Vs. Look at this relation. For all the current, means you pass whatever the amount of current, always it is equal to that what? Applied voltage. Got the point? It is independent ideal voltage. So suppose if you draw the characteristics in between terminal voltage and the current. Okay, I am considering terminal voltage on y-axis, current on what? X-axis. What will be the value of terminal voltage? It is always is equal to source voltage. So constant value Vs for all the time, it is equal to Vs. This is the way we get what? Characteristics for what? Ideal voltage source. As I said, independent means there won't be any dependency on the what? Particular circuit. Okay, this is the behavior for independent ideal voltage source. So how you can give the definition? Terminal voltage is independent of current flowing through it. Simple statement you can give, then it becomes what? Ideal voltage source. What will be the difference exactly when it comes to the what? Independent practical voltage source. Practical voltage source means definitely dependency will be there. Dependency means terminal voltage is depending on the current flowing through it. Because of that, it becomes what? Practical source. Means in practice, definitely if you look into that any generating stations, generators will deliver the what? Energy, but look at those output terminals, only voltage will come out. So in practice only voltage sources you can find. There won't be any current sources exist, only for convenience. We are just replacing and even calculating for convenience part, but in practice only voltage source, batteries you take or generators you take, only those are exhibiting the what? Voltage. But ideal voltage source you cannot indicate, not possible. What is the reason? Ideal voltage source means what is happening here? Terminal voltage is independent of current, means when it is possible, then there is no internal resistance. Internal resistance is 0 for that source, is not possible. Definitely generator will have some internal impedance, even battery also will have some internal resistance. Generally not possible here. But when it comes to practical source will have the what? Internal resistance. So when it comes to the practical voltage source, definitely internal resistance is present. There will be a what? Dependency of the terminal voltage in that particular circuit current. So we'll draw that circuit. You will find the what? Difference here. Okay, so this is the what? Source voltage, same like Vs I am indicating. Now how to have the what? Dependence? Suppose if I am indicating with this terminal voltage, how that dependency will come? Definitely I should place some internal resistance that is in series. If I place that series parallel resistance, then there won't be any difference, because same voltage is available across the resistance, again same voltage that is coming. So that is the reason why directly I am writing the resistance in series with that. When you place in series only, because it forms a loop, so when you write the KVL, again that resistance drop will come into the picture. Because of that term only, dependency is coming for the terminal voltage. That is the reason why we are not placing resistance in parallel. Got the point? That is the difference. Okay, why we choose internal resistance in series, especially for this voltage source. Okay, so current through the circuit I am indicating with I. Now follow with that same rule. KVL, if you just write here, what we will get? Terminal voltage I am indicating. If you place any element here, I am just following with this current direction, right? Algebraic sum of voltage in a closed path is 0. Current entering into negative terminal, so minus sign I am indicating. So it is a passive element, so it can allow the current in either direction. It is a bilateral based on this current direction. This must be the word polarity. So what is the voltage drop across the resistance? Voltage means current into resistance by using Ohm's law, that is we get I into Rs only will get, and current entering into positive terminal means plus Vt will come, which is equal to 0. Now our intention is to write expression for terminal voltage. So Vt is equal to, if I write these terms into right hand side, we get Vs minus I into Rs. Look at this expression. Earlier ideal source means there won't be any term related to current, so it is independent of that, so we are naming it as ideal. Now terminal voltage is depending on this current. Suppose if I choose current 0 means Vt is equal to Vs. Means if there is no element, no resistance, means it seems to be open circuit. How much voltage you are giving, that is available across the terminal, so that is happening. Slowly, if current increases, automatically terminal voltage decreases means drooping nature will come. When you draw the characteristics, what we get, we are drawing with respect to current the circuit, terminal voltage with respect to current the circuit. Current is 0 means it is Vs, but when current increases, this is the behavior we get. This is our practical voltage source. I am drawing the dotted line for what? Ideal. This is the difference. This is ideal and this is what? The practical. Look at here. Drooping nature means a negative slope. That is the reason why always active elements will have what? Negative slope only. Got the point? Even though active elements means sources present in the circuit, we are not naming it as what? The passive network, because overall we are not naming it as what? Active network, because only that active nature is associated with that particular element only. Reason is what? Their VI characteristics not like a passive behavior, because slope is what? Negative. But overall network point of view, you can name it as what? The passive network only. Only we are restricting that towards only what? Element category here. So sources generally what? Having active nature. Got the point? Because of this behavior. But in practice only these are exist, okay, right? Ideal is generally not possible with this behavior. Internal resistance won't become what, zero in practice. Okay, so when you just even write the overall properties, what you can compare here, RS present here but there is no internal resistance. Compare in series form, what is the property you can write? Properties, if you write internal resistance is what, RS I am indicating, internal resistance is what, 0 here, but here internal resistance exists. I am naming it as what, internal resistance. So I am just writing exists because some value is present. It could be any value, that depends on the what, a particular circuit. Okay, next we will look into that another category here. Next category is what, current sources. Here also we have ideal as well as what, practical current sources, that is independent only. Current source means definitely it should indicate the word direction, right? First, when you choose a ideal current source, I am going with this kind of direction for the source. I am indicating some value here. Now if you connect it to any like a circuit or terminals or any element, definitely two terminals only present. Here I am indicating some voltage for these terminals, that is V or VT, whatever the notation you can take. Definitely current will be what, even flowing through this, that I am indicating with this current what, I. When you connect any element, current I will be flowing. Ideal we are writing here. At this moment, as I said, okay, KCL is also not discussed, but we need to use that. Here a node or a point or junction is present because it is a source one element, and when you connect another element here in between two elements, a common point or junction is there, node is present. Node means you can apply the what, KCL. Loop means we are writing what, KVL. Here node means we are applying the what, KCL. What is KCL? At a node, algebraic sum of either you can take incoming or what, outgoing current must be what, 0 here. But what is the standard statement? At a node, algebraic sum of leaving currents is what, 0. Algebraic means definitely incoming, if you choose one notation, outgoing must be opposite to that. There won't be any limit. You can choose incoming positive, then outgoing becomes what, negative. Incoming, if you consider negative sign, outgoing becomes what, positive. That is opposite indication we need to take because we are taking what, algebraic sum. Now apply the what, KCL for this node. Then what will be the incoming current? If I choose incoming current with the negative sign, that is minus Is, outgoing current is what, plus I. Okay, algebraic sum must be what, 0 we are saying. By this what will be the current? I is equal to Is. You can have whatever the voltage across the terminals, but always current flowing through these terminals must be equal to our source current. So I am writing for all the voltage V. If you draw the characteristics with respect to voltage V for this current I, it is always is equal to what, source current. Okay, just like a step signal we need to indicate, right? This we are naming it as what, ideal current source. Even we are naming it as independent because it is not depending on any another variable in the what, particular circuit. So overall what we are naming, independent ideal current source. Now next, when you go with practical, how you can have practical means dependency must be there. Okay, this current, if it is depending on any other like a voltage, this voltage, then it becomes what, practical. How to have that connection here? Look into this. Now if I am placing as it is, okay, this is our source current Is, okay, and this is our terminal voltage I am indicating V, and if I am connecting any another element and it is carrying current what, I. So how to make dependency for the current on this variable, if I place a series element, series resistance or series impedance, same current is flowing through this, there won't be any dependency on this. That is the reason why we are placing a what resistance in parallel. This is just opposite. Okay, earlier practical voltage source means we are placing resistance in series. Now if it is current source, definitely you should place parallel, then only the dependency will come, then only it becomes practical source. Now look at here, when you place a parallel at this node, earlier Is is incoming and I is outgoing. Now another branch is came, so some even current will be flowing. That source current will be divided for the branch resistance as well as what another current, that is what I. At this moment, if you write the word KCL at this node, okay, if I choose this current direction, incoming current is what Is. As I said, incoming, if you choose one notation, outgoing must be opposite to that. Here I am choosing incoming with the negative sign, that is minus Is. These two are what outgoing branches, so I am placing positive sign. What will be the current flowing to this resistance? Definitely you should know what will be the voltage across this. What is the voltage across this? This terminal voltage V only. So current I am writing in terms of voltage resistance by using Ohm's law. I is equal to V by R concept, that is V by Rs we will get. This is the current flowing to this resistance. Again, what is the current flowing to this terminal? That is I only, which is equal to 0. Now our interest is to write expression for the current I. So I is equal to, if you write these two terms into right hand side, we get Is minus V by Rs. Look at this expression. Earlier current is what independent of this voltage. Now current is depending on this voltage V. If you draw the characteristics, okay, similar to our practical voltage source, like that only we get. If you choose 0 voltage, so what we get? 0 voltage means I is equal to Is only. 0 voltage means if there is no element here, okay, starting. And if keep on voltage increase means when we have resistance here, automatically current decreases. This is the drooping nature, okay, practical. And if I indicate dotted line with what? Ideal. This is the comparison between what? Ideal and practical. Now coming to the internal resistance, okay, that we are writing here. What will be the internal resistance? Compare with this practical. Here you can write internal resistance with what? Internal resistance of practical current source is how much here? Rs. Compare with that same fashion, you can indicate with what? With this notation. What will be the value here? Open circuit we have. So what will be the internal resistance here? Internal resistance means open circuit means Rs will be infinite here. That is the difference when you compare with what? Ideal voltage source. Okay, ideal voltage source is having internal resistance 0, but ideal current source internal resistance is infinity. Whereas practical voltage source, practical current source will have some resistance value. Okay, that is the difference between the what? Voltage and current sources. But in practice, in nature, only voltage sources exist. And one more thing, you can find the relations in between voltage, current, linear, not linear, like non-linear category. That is the reason why we are naming it as what? Active elements. Active elements, but bilateral, because these can allow the what? Current in either direction. But what we can say means when you connect it to element, okay, element could be bilateral like RLC, but active elements and unilateral we are saying for what? Source point of view. Sources are what? Active and unilateral element. But other elements you can have the what? Passive and what? Bilateral elements in the circuit. This is in terms of the what? Independent source point of view. Next we will look into that what? Dependent sources. Now we will look into that dependent source. Now we can even call it as a control source also. Means source means definitely voltage or current, but how that voltage or currents are depending on another variable. Variable means again either voltage or current only present here. We already listed that classification. Okay, now we'll see examples directly. Reason is what even dependent or control source are also we can even categorize into linear as well as what non-linear. Again you may find some difference here. Source itself is a what the non-linear element, but we are talking about the relation between the what particular source and dependent variable. Based on that we are commenting on linearity and non-linearity. But basically source means you take independent or dependent source, that must be what non-linear element only. I am talking about linearity on the basis of particular source and the what that particular dependent variable. Okay, now when you see the examples directly, dependent source we are indicating with the diamond shape. It could be what either voltage or current source. Voltage source means polarity we indicate, current source means the direction we choose here. Now look at here, this is what dependent. If I choose this polarity, it is a voltage source, but variable will decide what kind of dependent source it is, like K1 into Ix. What is the meaning? It is a current controlled voltage source. Polarity indicate that source, and here the variable decide what is the category. What you can name it is current controlled voltage source. Similar manner, if I am even drawing some other sources, right, direction if I indicate, this is what current source, and the variable decide what kind of dependent source it is, like M into V2. So what you can name it is voltage controlled, it is a current source. Like different possibilities I am choosing here. Now if I choose another polarity, right, like this time 24 into V3, like it is also voltage controlled voltage source only. Next one is what suppose if I am going with again a current source here, direction current source, and got the point, 2 into Ix, like that I am taking. So it is current control current source only. But if you look into all these relations, what kind of relation, like it is current only, but the simple Y is equal to Mx format. Voltage Y is equal to Mx, current or like Y is equal to Mx. Similar way, all these comes under what linear category, linear dependent or controlled sources. Okay, next I am taking some other examples for non-linear controlled sources. It is a voltage source, but I am writing like this. So it is a current control voltage source only, but it is not Y is equal to Mx format. Okay, non-linear relation is there. So you can name it as what, non-linear control source. One more example I am taking here, current source I am indicating, and I am writing like 4 into Vx power 3 by 2, like voltage controlled current source. These two you can name it as what, non-linear controlled sources, right? So based on the relation of the dependent variable, we categorized into linear, non-linear control sources. But basically source means it is a non-linear element only, based on the characteristics part I am giving. Okay, this is the classification in the what source elements.